Hello my dear students, I warmly welcome you to CR's digital classes. In this video, we are going to see the introduction of numbers and divisibility, and we are going to learn the divisibility rules of particular numbers. Now, the divisibility of 1. So every number is divisible by 1 as it is an universal divisor. Now coming to the second number, which is number 2. A number is divisible by 2 when it is an even number or that particular number ends with 0 or 2 or 4 or 6 or 8. So for example, I have 128. 128 as is an even number, so it is divisible by 2. But 129 is an odd number. It is not divisible by 2. Next, divisibility rule of 3. The divisibility rule of 3 says that the sum of the digits should be divisible by 3. For example, I have 381. 381. So here the digits are 3 and 8 and 1. So what should I have to do is I have to add these 3 digits, which is 3 plus 8 plus 1. This gives me a value of 12. So if the value is divisible by 3, then the number is divisible by 3. So 12 is divisible by 3. So 381 is also divisible by 3. In the same way, 217. 217. Let us add these digits. 2 plus 1 plus 7 gives me a value of 11. But the number 11 is not divisible by 3. So 217 is not divisible by 3. Now coming to the divisibility rule of 4. The divisibility rule of 4 says that the last 2 digits of that particular number should be divisible by 4. Then it is divisible by 4. For example, 1312. The last 2 digits are 12. So 12 is divisible by 4. So 12 is divisible by 4. That particular number, which is 1312 or 1312, is divisible by 4. In the same way, 7019. The last 2 digits are 19, but 19 is not divisible by 4. As 19 is not divisible by 4, then that particular number 7019 is not divisible by 4. Now coming to the divisibility rule of 5. The divisibility rule of 5 says that the number should end with 0 or 5. If the number is ending with 0 or 5, then it is divisible by 5. Now 175, it is ending with 5, it is divisible by 5. But 809 is ending with 9, so it is not divisible by 5. Now coming to the divisibility rule of 6. Divisibility rule of 6 is nothing but the divisibility rule combined of 3 and 2. So 6 can be written as 3 into 2. So the combined divisibility rules of 3 and 2 gives us the divisibility rule of 6. So if a number is divisible by 6, then it should be divisible by 3 and also divisible by 2. For example, 114. 114, is it divisible by 2? As 114 is an even number, it is divisible by 2. So next, what should I have to do? I have to check whether 114 is divisible by 3 or not. So the divisibility rule of 3 says that the sum of the digits should be divisible by 3. Now sum of the digits, 4 plus 1 5, 5 plus 1 6. Is 6 divisible by 3? Yes. So the number 114 is also divisible by 3. As it is divisible by both 2 and 3, it is divisible by 6. In the same way, 308. 308. Is it divisible by 2? Yes, it is divisible by 2. We have to check whether it is divisible by 3 or not. So 8 plus 3. 8 plus 3 is 11. 11 is not divisible by 3. So the number is not divisible by 3 and also it is not divisible by 6. So next, the divisibility rule of 7. The divisibility rule of 7 says that what we have to do is we have to take the last digit from that number and we have to double the last digit. What we have to do, we have to take the last digit from that number and we have to double that particular number and subtract it from the remaining number. For example, I have a number of 1729. what I have to do is I have to take the last digit of that particular number and I have to double it. So 9 2s are 18. Then what I have to do is I have to subtract this 18 from the remaining numbers, which are 172. 172 minus 18. So 6, 12. So 4 and 154. Now, is 154 divisible by 4? We have to check. As 154 is divisible by 7. So what we have to do is we have to check whether 154 is divisible by 7. As 154 is divisible by 7, then this particular number, which is 1729, it is also divisible by 7. In the same way, 672. Let us say 672. What we have to do is we have to take the last digit and double it. 2 2s are 4. Now we have to subtract it from the value. 67 minus 4. 67 minus 4 is 63. Is 63 divisible by 7? Yes, it is divisible by 7. So this particular number 672 is also divisible by 7. So this is divisible by 7. But 905 is not divisible by 7, as 80 is not divisible by 7. Now coming to the divisibility rule of 8. The divisibility rule of 8 says that the last 3 digits should be divisible by 8. The last 3 digits should be divisible by 8. For example, 109816. Is 816 divisible by 8? We have to check that itself. So if 816 is divisible by 8, then it is divisible. Then that particular number is divisible by 8. Now 816 is divisible by 8. So the particular number 109816 is divisible. But 216302. We are checking 302. If 302 is divisible by 8, then the particular number or the whole number is divisible by 8. But 302 is not divisible by 8. So 216302 is not divisible by 8. Now coming to the divisibility rule of 9. The divisibility rule of 9 and the divisibility rule of 3 both are same. 3 and 9 both are same. Both these say that sum of the digits should be divisible by 3 or 9. If a number is divisible by 3, then sum of digits should be divisible by 3. In the same way, if the sum of the digits are divisible by 9, then it is divisible by 9. For example, 1629. 1629. So let us add these digits. 1 plus 6 plus 2 plus 9, which gives me 18. Is 18 divisible by 9? Yes, it is divisible by 9. So this particular number is divisible by 9. In the same way, 2013. 2 plus 0 plus 1 plus 3. So 2 plus 1, 3. 3 plus 3, 6. Is 6 divisible by 9? No, it is not divisible by 9. Then this particular number is not divisible by 9. Now coming to the divisibility rule of 10. Divisibility rule of 10 is very simple. A number is divisible by 10 when the last digit of that number is 0. So 220 is divisible, but 221 is not divisible. Now coming to the divisibility rule of 11. Divisibility rule of 11 says that what we have to do is we have to add these alternate digits. We have to add alternate digits and subtract them. We have to add even alternate digits and we have to add all alternate digits and subtract them. First, suppose I have a value of 1331. What I have to do is I have to add these alternate digits. Now 1, next alternate digit is 3. 1 plus 3. In the same way, 3 alternate digit is 1. 3 plus 1. Now what I have to do is I have to find the difference between them. I have to find the difference between them. So 4 difference 4. So difference after subtracting, if I am getting a value of 0 or 11 or any multiple of 11, then the whole number is divisible by 11. So 4 minus 4 is 0. So we are getting a value of 0. Then this particular number, which is 1331, is divisible by 11. In the same way, let us check 1364. What we have to do is we have to add these alternate digits. 1 plus 6 difference of alternate digits of 3 plus 4. 1 plus 6 is 7. 7 difference 7. 7 minus 7 is 0. We are getting a value of 0. So this particular number is divisible by 11. So divisibility rule of 11 is very important. You should remember this. Okay. The least value of x and y respectively so that 7x, 7x, 3, 4, 2, y. These are digits. Is divisible by 88. So whenever a number is divisible by 88, we can say that it should be divisible by 8 and also 11, as 88 is 8 into 11. So 8 into 11. So now we have to remember the divisibility rules of 8 and 11. So the divisibility rule of 8 says that last 3 digits should be divisible by 8. In the same way, 11 divisibility of 11 says that alternate digits should be added and then they are to be subtracted. Their difference should be formed. If that difference is 0 or 11, then it is divisible by 11. Let us substitute the divisibility rule of 8 here. So our number is 7x 3, 4, 2, y. Divisibility rule of 8 says that last 3 digits should be divisible by 8. Now last 3 digits are 4, 2, y. It should be divisible by 8. Now 8 5s are 40. The remainder is 2. Then y. Whenever a number is completely divisible by a particular number, then we are getting a remainder of 0. Now 8 multiples which gives a value nearer to 20 something. It is 8 3s are 24. 8 3s are 24. Now we have to get a remainder of 0. In the place of y, what should I have to substitute? In the place of y, when I substitute a value 4, then I am getting a remainder of 0. Then our y value is 4. We are getting a y value of 4. Let us substitute it here. 7x 3, 4, 2, y is 4. Now we have checked the divisibility rule of 8. Now what we have to do is we have to check the divisibility rule of 11. Let us apply the divisibility rule of 11. So divisibility rule of 11 says that alternate digits should be added and then subtracted with the other alternate digits. So 7 plus 3 plus 2, difference of x plus 4 plus 4. X plus 4 plus 4. 7 plus 3 is 10. 10 plus 2 is 12. 12 difference x plus 8. This value should be equal to 0 or 11. It should be equal to 0 or 11. Let us equal this to 0. Now 12 minus x minus 8 is equals to 0. Then 12 minus 8 is 4. Minus x goes that side. It will become plus x. So x value is 4. Now we have got the values of x and y. So x is 4 and y is 4. So our answer is option C, which is 4, 4. Now coming to the next question. A natural number m is multiplied by 11 and then 22 is added to the product. First, suppose I have a number m. It is multiplied by 11 and then this product is added to 22. Then the result is a multiple of 17. This result is a multiple of 17. It is 17 into some k value. Now what I have to do is I have to substitute options in this particular equation. Let us substitute first option in this equation. So m is 11. 11 into 11 plus 22. So 11 11s 121. 121 plus 22. 121 plus 22 is 143. So 121 plus 22 is 143. Is 143 a multiple of 17? Or 143, is it divisible by 17? No, it is not divisible by 17. So our first option is not the answer. Now coming to the second option. So 15 into 11. M is 15. 15 into 11 plus 22. 15 into 11 is 165. 165 plus 22. 165 plus 22 is 187. Now let us check if 187 is divisible by 17. Is 187 divisible by 17? Yes, it is divisible by 17, as 17 into 11 is 187. So our answer is option 2, which is 50. Now, coming to the third question, it is an really good question. If 2 to the power of k divides 19 factorial, then the largest positive integer of k. Now we have to find the k's largest value. What is he saying in this equation? He is saying that 19 factorial is, or 2k, 2 to the power of k divides 19 factorial, which means 19 factorial divided by 2k. 2k is completely dividing the 19 factorial. 19 factorial can be written as 19 into 17 into 18 into 19 into 18 into 17 into 16 into 15 into and so on up till 3 into 2 into 1 divided by 2 to the power of k. Now what he is saying is how many 2's are there in this above multiplication. He is asking how many 2's are present in this above multiplication. Now let us see here. In 18, I am getting a single 2, 2 into 19. In 16, I have 4 2's, 2 to the power of 4. In the same way, 2 is 2 to the power of 1. Now, what I can do or we can do is, we have to count, we have to write these numbers from 19 to 1 and count how many 2's are there. Or I can simply solve this with simple equation or simple prime factor method. Now 19, 2, we have to find how many 2's are there in 19 factorial. Let us divide 19 by 19 with 2. So 2 9's are 18. So don't consider these reminders anything. Let us divide. 2 9's are 18 and again 2 4's are 8. Then again 2 2's are 4. Then again 2 1's are 2. Now what I have to do is I have to remove this 19 and add all these numbers, which is 9 plus 4 plus 2 plus 1. So 9 plus 4 plus 2 plus 1 is 16. Now in 19 factorial I get 16 2's, or I can say that I am getting 2 into 2 into 2 into this 16 times. So here the k value is 16. Here he is asking what is the greatest k possible k value. So the greatest possible k value is 16. So our answer is 16, which is option C. Now coming to the fourth question. What is the least integer which gives remainder 0 when divided by 2? When it is divided by 2, we are getting a remainder of 0. Then we are getting a remainder of 4 when it is divided by 5. We are getting a remainder of 3 when it is divided by 7. Let us check with the options. Now, if a number is divisible by 2 and we are getting a remainder 0, then it should be an even number. So, first one is an even number, second one is an even number, third one is an even number, but the fourth one is not an even number. So, fourth one is ruled out. Now, whenever we are dividing it with 5, we are getting a remainder of 4. So, first one is giving a remainder of 4, second one is also giving a remainder of 4, third one also is giving a remainder of 4. Now what we have to do is we have to check whether when we are dividing with 7, if we are getting 3 or not. Now let us check first option, which is 164. Let us divide it with 7. 7 2's are 14, 24, 7 3's are 21. Yes, we have got a remainder of 3. So our answer is 164, particularly 164, as whenever we are dividing it with 2, we are getting a remainder of 0. Whenever we are dividing with 5, we are getting a remainder of 4. And when we are dividing with 7, we are getting a remainder of 3. So our answer is 164. Thank you for watching this video.